All right, what we're going to do today is we're going to look at how to find the slope of a line that's tangent to a graph at a specific point. And this is one of the main themes that's going to run all through the first part of Calculus 1. And it's using a limit, and we're going to soon discover that this limit is going to be called a derivative. But to use the limit, what we need is a graph, an equation of a graph, and a specific point that we're interested in for the tangent line. So if you look at our graph right here, we do have a specific equation, y equals x squared. We do have a specific point, 2 and 4, and we've got a graph. So we know at the point 2, 4, right there, we want to have a tangent line that looks something like this, where it touches that graph in just that one point. See if I can line it up just perfect here. And then we want to know what the equation of that line is. Okay? And so it touches at exactly one point. Well, how do we do that? We use this limit rule down here, remembering that we're really interested in the slope of the line at that point. So, some things. 1, we're going to use this limit formula. 2, we know that our x-coordinate for this particular problem is 2, and we know that the y-coordinate for this particular problem is 4. Now, we may need both of those, we may not, but we're going to go ahead and list what we know. And then, down here on the bottom, we've got x equals a, and we know what x is. We know what a is. It's going to be 2. So, everywhere we see that x, we put the 2 in. So my problem looks like this. I'm going to have the limit as h approaches 0 of f of x plus h, and in this case that's going to be 2, minus f of 2 all over h. So what does all of this mean exactly? Well, our function is y equals x squared, okay? So f of x is equal to x squared. F of 2 plus h would look like 2 plus h squared. Everywhere that you see x, you put 2 plus h in. And FOIL it out. So you're going to have 4 plus 4h plus h squared. And then the last one is the function of 2, at 2, f of 2. And again, everywhere we see x, we put a 2 on it to its place. So it's 2 squared, which is 4. When we set this limit up, then, we're going to have f of 2 plus h, which is this purple guy, minus f of 2, which is the green guy, all over h. Now, we'll know that we have set this up correctly when we look and we cancel some things out, and all we have is 4h plus h squared. And so when we do this, we can factor that h out on the purple. Notice we've got h's everywhere. And then the h's cancel. Wait a second. This should be 4 plus h. There we go. And so then the h's cancel out, or divide out, or cross out, and you're left with the limit as h approaches 0 of 4 plus h. And now we can substitute that 0 directly in, and we get 4. Okay? So that's the slope of the parabola when the x-coordinate is 2. The slope m is equal to 4. Now, then it says, write an equation for a tangent line. And in order to write an equation for a tangent line, we're just going to remember that we're going to have y2 minus y1 equals m times x2 minus x1. And we just substitute in those values. Remember, we already have an x value and a y value. So this is going to be a perfectly acceptable equation for me. We're going to have y minus 4 equals 4 times x minus 2. I am 100% satisfied with this equation. If you want to dress it up a little bit, you can move the 4 with the y to the other side. And if you want to go ahead and simplify down even more, that's totally fine. But both of these answers right here are good answers. And this is how you find the equation of a tangent line at a specific point of a function.